Okay, so this is Module 3, Question 14, and this is a problem that really can't explicitly be done using StatCrunch. So one of the good things to do is to go through a help me solve this or an example to show how the formula is being used, because this is a very formula-heavy problem. So first of all, we're looking for sample size given that we have a certain percent confidence and we have the standard deviation. So if you go to question help, and again, you can go through help me solve this if you'd like to. I'm just going to go through view an example. This is the formula for n, given that you know what percent confidence and your standard deviation. It also requires that you need your error, standard error. So if you look here in the problem, just to show you where you get your standard error, it says that you want the mean HDL cholesterol within 4 points. So that within 4 points is telling you that that is your standard of error. That error is the plus or minus that you can be in order to get as the sample size that you want. So here, if I look at this again, first off, I need that z-score. Now to get the z-score, we've been through this a couple of times before in a few other problems, but you're going to go to StatCrunch. And then in order to get the z-score, I'll go to Stat and ZStats. Stat, Calculators, and then Normal. And in this case, I wanted to be 99% confident. So we're going to change this to between and put 0.99 down here. And that gets me a z-score of 2.57, we'll call it 6. So that means that in order to do this formula, I'm going to do 2.576 times whatever s is, in this case it's 12.2. Then I'm going to divide by 4. So 2.576 times 12.2 divided by 4, get that answer, and then square it. And that will get me my answer for my sample size. Now the next thing they'd like you to do is then go ahead and change this to a different percent confidence and see how that changes the sample size. So I'll go back to StatCrunch and I'll change this to 90% instead of 99% and use the 1.645 as my z-score. So here, again, just so you can see the formula, it would be 1.645 times whatever this is, it's 12.2 out here, divided by my standard of error, which we again said was 4 because they wanted within 4 points, and then square that. And you can do all that on a standard calculator.